Virtual networking is a cornerstone of cloud infrastructure, enabling communication between resources in a cloud environment. In the context of Microsoft Azure, virtual networking encompasses a range of services and configurations that ensure seamless connectivity, security, and performance. This presentation will delve into two critical aspects of virtual networking: name resolution and load balancing. Understanding these components is essential for any Azure administrator aiming to optimize network performance and reliability. Name resolution is the process of translating human-readable domain names into IP addresses that computers use to identify each other on a network. In Azure, name resolution can be managed through Azure DNS, which provides a reliable and scalable way to host your DNS domains. Azure DNS allows you to manage DNS records using the same credentials, APIs, tools, and billing as your other Azure services, ensuring a unified management experience. Azure DNS offers several key features that make it a robust solution for name resolution. These include high availability, fast performance, and seamless integration with other Azure services. Azure DNS supports all common DNS record types, such as A, CNAME, and MX records. Additionally, it provides advanced features like DNS alias records, which allow you to map a DNS name to an Azure resource, and private DNS zones, which enable name resolution within a virtual network without exposing DNS records to the internet. To configure Azure DNS, you first need to create a DNS zone in the Azure portal. Once the zone is created, you can add DNS records to it. These records can be managed through the Azure portal, Azure CLI, or Azure PowerShell. For example, to create an A record that maps a domain name to an IP address, you would navigate to the DNS zone, select Add Record Set, and enter the necessary details. Azure DNS also supports importing and exporting DNS zone files, making it easy to migrate existing DNS configurations to Azure. Private DNS zones in Azure allow for name resolution within a virtual network without exposing DNS records to the internet. This is particularly useful for scenarios where you need to resolve names for virtual machines and other resources within a private network. To create a private DNS zone, you can use the Azure portal, Azure CLI, or Azure PowerShell. Once created, you can link the private DNS zone to one or more virtual networks, enabling name resolution across those networks. This setup enhances security and simplifies network management. Load balancing is a technique used to distribute incoming network traffic across multiple servers or resources to ensure no single server becomes overwhelmed. In Azure, load balancing is crucial for maintaining high availability and performance of applications. Azure offers several load balancing solutions, including Azure Load Balancer, Application Gateway, and Traffic Manager. Each of these services is designed to handle different types of traffic and use cases, providing flexibility and scalability for your applications. Azure Load Balancer is a Layer 4 TCP/UDP load balancer that distributes incoming traffic across multiple virtual machines or services within a region. It supports both public and internal load balancing, making it suitable for internet-facing applications as well as internal workloads. Key features of Azure Load Balancer include automatic reconfiguration, health probes, and support for both IPv4 and IPv6. To configure an Azure Load Balancer, you need to create a load balancer resource, define a front-end IP configuration, and set up back-end pools and health probes. Azure Application Gateway is a Layer 7 HTTP/HTTPS load balancer that provides advanced routing capabilities for web applications. It supports features like URL-based routing, SSL termination, and Web Application Firewall, WAF, to protect against common web vulnerabilities. Application Gateway is ideal for scenarios where you need to manage traffic based on HTTP attributes, such as host headers and URL paths. To set up an application gateway, you need to create the gateway resource, configure listeners and routing rules, and associate it with backend pools. Azure Traffic Manager is a DNS-based load balancer that enables global distribution of traffic across multiple regions. It uses DNS to direct client requests to the most appropriate endpoint based on the configured traffic routing method, such as performance, priority, or geographic routing. Traffic Manager is particularly useful for achieving high availability and responsiveness for applications with a global user base. To configure Traffic Manager, you need to create a Traffic Manager profile, define the traffic routing method, and add endpoints representing your application instances. To configure an Azure load balancer, start by creating a load balancer resource in the Azure portal. Next, define a front-end IP configuration, which can be either public or private. Then, set up backend pools to specify the virtual machines or services that will receive the traffic. Health probes are essential for monitoring the health of backend instances and ensuring traffic is only directed to healthy instances. Finally, create load balancing rules to define how traffic should be distributed across the backend pool. These steps can be performed using the Azure portal, Azure CLI, or Azure PowerShell. Setting up an Azure Application Gateway involves several steps. First, create the Application Gateway resource in the Azure portal. Next, configure the front-end IP, which can be public or private. Then, set up listeners to define how the gateway should listen for incoming traffic. Routing rules are used to determine how requests are forwarded to backend pools based on URL paths or host headers. Additionally, you can enable features like SSL termination and Web Application Firewall (WAF) for enhanced security. These configurations can be managed through the Azure portal, Azure CLI, or Azure PowerShell. To configure Azure Traffic Manager, start by creating a Traffic Manager profile in the Azure portal. Choose a traffic routing method that best suits your needs, such as performance, priority, or geographic routing. Next, add endpoints representing your application instances, which can be Azure services, external endpoints, or nested Traffic Manager profiles. Traffic Manager will use DNS to direct client requests to the most appropriate endpoint based on the chosen routing method. You can monitor the performance and health of your endpoints through the Traffic Manager dashboard in the Azure portal. Effective monitoring and troubleshooting are crucial for maintaining the performance and reliability of your name resolution and load balancing configurations. Azure provides several tools for this purpose, including Azure Monitor, Network Watcher, and Application Insights. Azure Monitor offers comprehensive monitoring and alerting capabilities, allowing you to track metrics and logs for your DNS and load balancing resources. Network Watcher provides network diagnostic and visualization tools, while Application Insights offers deep insights into application performance. Utilizing these tools can help you quickly identify and resolve issues, ensuring optimal network performance. Implementing best practices and security measures is essential for optimizing your name resolution and load balancing configurations. For name resolution, consider using private DNS zones to enhance security and reduce latency. Regularly review and update your DNS records to ensure accuracy. For load balancing, use health probes to monitor the health of backend instances and configure appropriate failover mechanisms. Implement SSL termination and Web Application Firewall (WAF) for Application Gateway to protect against common web vulnerabilities. Regularly review and update your configurations to adapt to changing requirements and threats. Configuring name resolution and load balancing are critical components of managing virtual networking in Azure. By understanding and implementing these configurations, you can ensure high availability, performance, and security for your applications. As an Azure administrator, it's essential to stay updated with the latest features and best practices. Consider exploring additional Azure services and tools that can further enhance your network management capabilities. Continuous learning and hands-on practice will help you master these concepts and effectively manage your Azure environment.